Good afternoon, we are now live.
Hello, good afternoon. My name is Vincent Garnier. I'm the Director General of the FTTH Council Europe. And I would like to welcome you to this new session of our webinar series. The title for today's session is Deutsche Telekom's Journey to Accelerate FTTH Deployment. And before I introduce you to our speakers, I would like to spend a few minutes to explain a bit more the series of webinar we're presenting and run you through some housekeeping items. So if you can move to the next slide, please. For those who are not familiar with our organization, the FTTH Council is a trade association. We are regrouping 160 members, both coming from the vendor community, operator community, and investors, under the objective to promote full fiber network as the most future-proof and sustainable broadband access technology for the benefits of European citizens and businesses. We are conducting multiple studies, work. We are advocating towards policymakers, but we're also educating the ecosystem, and this series of webinars is part of our effort to share insights and knowledge about our industry. Next slide. So this series takes place once every 3 weeks, once every month, and is sponsored by typically the member of the FTTH Council. And today's session is sponsored by IQGeo with 2 representatives, Ralf Messmann and Jonas Verstuyft. IQGeo being a very active member of the FTTH Council. Next slide. So some very practical information. The session is recorded. Every person having registered to the session will have access to the replay. We will also share the deck, which will be used by our presenters. So the deck will be reachable via the thank you email you will receive. You are welcome to ask questions. We will dedicate 10-15 minutes toward the end of the presentation to answer this question. To do so, you need to use the question section of the control panel you must have on your screen. So do not hesitate to type the question. We will do our very best to address most of them. In case, because there are many attendees today, in case we cannot take your question, they will be forwarded to the sponsor and participant to this session, and I'm sure they'll come back to you in one way or another. So with that, I would like to move to the next slide and hand it over to Ralf Messmann, who is leading IQGeo for Europe. And Ralf will tell you more about the topic of today and introduce the following presenters. Ralf.
Yes, thank you very much, Vincent, for the introduction, and also from me, yes, a very warm welcome to everyone here on this webinar. I'm really excited to be able to present to you today a customer use case on the usage of Comsof fiber within the context of the Deutsche Telekom project, and happy to have our guest speakers from Deutsche Telekom joining us. First, I want to give you a short intro to IQGeo for those who are not familiar with the company. Our vision within IQGeo is that we are helping our customers really building better networks. And we do that with a quite unique single integrated solution that can help all the operators to support the whole life cycle of the network. So all the way from the planning and design stage through to the construction, and then ultimately operating the network, and of course also connecting customers in order to generate revenue. And we do that in a way that is quite unique, from one source of truth, one platform that underpins all these different parts of the life cycle. Now, for those who are also familiar with Comsof as a company and as a brand, so since August 22, IQGeo and Comsof have joined forces. And given the fact that our technologies are very complementary, this now fits into this end-to-end lifecycle story, obviously being one company now with a broad set of solutions, and where the Comsof brand is mostly reflecting the automated design solutions. As a joint company, we have more than 450 customers across the world and more than 100,000 users that are daily using our software, something we are very proud of. We are with more than 300 employees spread across our 8 offices that are spread also around the world. And I think what's differentiating us from some other companies is that we really come from a real understanding of the networks and the support of the workflows. We start from the business problem and look at implementing solutions to solve those business challenges. And that with a team with a lot of experience in this domain. And like I said, spanning the whole life cycle. It's also a system that is very modern, cloud-based, very easily supporting mobility workflows, etc. Now, the Comsof brand, as I said, is the part that focuses more on the automated design, so the earlier stages of a typical life cycle of a fiber network. And as such, Comsof product is a global market leader in automated design with a history of almost 20 years of supporting FTTH rollout projects across the world with some of the biggest projects out there. And of course, we're very happy today to zoom in a bit more on one of the projects we're very happy and proud of collaborating with, which is the project together with Deutsche Telekom. We are working together with Deutsche Telekom since 2018, where at that time the challenge was set forward to accelerate the FTTH rollout to at least 3 million homes per year at that stage, and increasing while doing so the quality and the consistency of designs. Deutsche Telekom selected Comsof as a solution, of course integrating that into a wider workflow, which we will learn more about in a few minutes. And the results, I think, are very interesting to see, reaching those high speed or high throughput per month with a high level of quality. And again, we'll come back to that in the following slides. So our speakers for today, I'm very happy to be joined by Bertolt von Schimmelmann and Henning Wolf from Deutsche Telekom, who are heavily involved in this journey and in this project. But before handing off to them, I'll hand off to Jonas Versterkt, who is within IQGeo responsible for the Comsof Fiber product, and who will first give us a quick run through of what Comsof Fiber is. Jonas, floor is yours.
Thank you, Rolf. Yes, so I want to start giving a high-level introduction of Comsof Fiber. With Comsof Fiber, we want to focus on 2 main questions that operators, engineering firms have when rolling out a new fiber network for a target area. How do I roll out that new network? What does that network look like? What equipment do I need to connect all of the homes in my target area? And how can I do this as cost effective as possible? How can I keep my costs under control? Well, with Comsof Fiber, which is a software solution, we try to do this by using design automation and optimization in many different ways. And I'm gonna walk you through that here. So the way that Comsof Fiber works is that it takes a set of rules and costs that are really driving the optimization. So you provide information on your network architecture, for example, cabinet size or the maximum distance that you can go to connect the homes. You provide a list of material and equipment, all the cables, ducts, closures, manholes, and so forth that you can use to build this new network. And you give it a set of costs and constraints. So all the equipment have a particular cost. They have some constraints on the amount of fibers, for example, for cables. There's cost for your civil works, for trenching, for aerial, or for reusing existing infrastructure. And there can be constraints on a closure size, for example, or the size of a manhole and the amount of closures that it can take. And all of that information is considered by the software and is driving the optimization algorithms. Second point is the GIS data. So it's really GIS driven to get to particular detail in accuracy, particular level in accuracy, and it's also driving the cost of the design. So typical GIS input data that's required is land-based data like the addresses, parcels, and streets within your target area. Any existing infrastructure, so that's a huge cost driver, as you'll also see in the presentation later on. Reusing existing conduits, existing cables, and structures is a way that costs can be lowered. So that's important that is also taken into account in the design automation. And then other cost driving factors like surface information, natural boundaries, all of that detailed information. The more detail that you provide it, the better the algorithms will work, and the more accurate the cost will be. As a result of a Comsof fiber calculation, you get very detailed output from the solution out of the box. So it gives you a cost breakdown, complete cost overview of building out your new network. And this goes into a lot of detail, so you get a detailed breakdown of all the equipment, all the civil works that are needed, together with the volume and the total cost. So you can do a very detailed analysis and maybe optimize your rules to drive down costs even further. This cost information can also be provided even for individual addresses for your target area. Again, driving your decisions to maybe exclude certain homes from an initial rollout and connect them later on, to then optimize the budget that you have for targeting a new area. And what is very important, I think, and helps with increasing the accuracy, avoiding errors, and gaining time, is that the output that's generated by Comsof Fiber is really a detailed design. So there's fiber level connectivity allowing you to trace through the network. So it's not only providing the equipment that you need to build out the network, but also which connections are required, like which fibers need to be connected to which other fibers, the cables in which a particular microduct do they need to be positioned. So all of this can be taken into account by the software. And last point, which I think is a key feature when going to low-level design and constructible designs, is giving control to the user. So it's not, Comsof Fiber is not a black box solution that gives you a design and you need to go with that. No, you can really have control. So you can make decisions, decide where your cabinet location needs to be, which homes are connected to which cabinet, for example, and let the software then do the heavy lifting and decide the connectivity again, decide all the equipment that needs to be placed to connect all of the homes that you told the software to connect. So you still have that level of control. It's not a black box solution. Now, with this functionality, we can offer, we see that with our customers, we're offering different types of values. First thing that's obvious, it's a time-saving solution, right? Compared to manual design, saving time for 50 to 90% in the end-to-end planning and design process. The second point, which is really important, is it's generating cost-effective design. So it's helping to reduce the build cost of your network. Definitely when looking to reuse existing infrastructure as efficiently as possible. A third point is you get better designs. So you get uniform designs. The quality is increased because you have a certain set of rules that need to be followed. If you're making changes to the design and you're not adhering to the rules, you get notified by the software, so it detects this and it notifies you so that you can adjust the design accordingly. It also helps to avoid mistakes. When doing a manual design, it's easy to miss a fiber or foresee the wrong type of cable so that you cannot connect homes maybe in a later phase. This is all taken care of by the software. And lastly, it's cost control. So already in your design phase, in your planning phase, you get a very detailed view on your costs. All the costs are generated or calculated based on a real network design following the rules. So the reduction in cost variation between design and build is greatly lowered. So you get a lot of confidence in the cost that you get from Comsof fiber design compared to the cost that it will take to eventually build a network. So this was a quick overview of Comsof fiber. And with this, I'm going to hand it over to Bertolt.
Thanks a lot, Jonas. Let me also share my screen. Okay, so based on Comsof fiber and with Comsof fiber in our portfolio, we basically established a program in Deutsche Telekom. But let me first give you a quick introduction. I'm assuming many of you are familiar with Deutsche Telekom as a company, but we're basically Germany's largest telecommunications company. We have like around 60 million mobile customers. We have around 20 million fiber connections, out of which 7 million approximately are FTTH connections or customers we can serve. We have had a massive build out of our FTTH footprint in the last couple of years. I think 2022 we had 2 million. 2023 with 2.5 million. 2024 is going to be 2.5 and between 2.5 and 3 million again. So we are massively ramping up our FTTH footprint. In 2023 alone, or this year, we by now have approximately 750,000 kilometers in fiber cable in the ground. And one of the main assets that helps build all of this in the last couple of years was the establishment of the FTTH factory, which is an end-to-end process to enable the fiber planning and construction process. And that's exactly what we want to give you a little bit more details about. So the FTTH factory process starts off with first an environmental recording. Henning is going to give you a little bit more details about that in a second, where we send our TCARs out. We then start off in the next process step, where we take the data that is recorded by the car and use AI components to do an automatic classification of the surface, and do then, based on that, also an automatic calculation of the potential trench network. We then start into the structure planning, where the Comsof components are embedded, go into virtual exploration, which is the process step where we do the permitting process, go then in a detailed design or detailed planning process, and lastly, hand over to a digital construction support step, where we support the construction itself and the documentation. And with that, Henning, I would pass over to you for the environmental recording.
Thank you, Bertolt. So our first step in our FTTH factory process is, as Bertolt said, the 3D and 2D environmental recording. Here we have currently 4 TCARs, so-called TCARs, so that's magenta car you see on the screen, driving around all of Germany. So this car is equipped with a lot of cameras and GPS receivers and 3D environmental sensors, so that all details of the construction area is recorded by this car. And currently these cars are sent to the city ahead of an FTTH rollout. And the starter is currently also only used for this FTTH rollout and is not made available for any third parties. And as you can see on the slide, the cars nearly drove 150,000 kilometers till today in the last 3 to 4 years. The next slide, Bertolt.
Sorry, it's slow coming up.
Okay, so let's have a closer look on our automated network design, in which we use a Comsof fiber designer. So the first step is to collect all the data gathered by the TCAR and this data is processed in an automated way, so that there's an automated classification going on the surfaces, so that we know on which side of the street which surface is present. So there are approximately 30 train classes for that. So, for example, asphalt and concrete, pavement. So all these different surfaces are collected and identified by our automated process. And out of this data, we generate the so-called potential trenches, which are then later used by Comsof. So these are the potential ways our network could be built, or FTTH network could be built inside one rollout area. And of course, these surface informations are written to this potential trenches. So we exactly know on which side of the street which surface is present, and of course how much this side of the street would cost. And these informations are then passed to our integration of the Comsof Fiber Designer. And so we generate a really cost optimized and good FTTH network design, also utilizing our existing infrastructure. And we already, thanks, Beto. We already generated, we already calculated in something like 12 million demand points over the last few years. So you can see in 2022 we started with 1 million households to be calculated by Comsof. And now we are nearly to 5 million in this year. And also this automated process reduced our fault up to 75% here. So in previous processes, our network designers really had to draw these FTTH areas manually, and that was not a nice job. And so we have a real good benefit here by using Comsof. And better to the next slide. So I would give you a little bit of experience here with working together with Comsof. Yeah, here it is. So in Deutsche Telekom, we had the special situation that we already have a lot of existing pipes and previously built fibers and so on in our company. So we wanted, of course, to reuse all these existing infrastructure which have been built over the years for our FTTH rollout to reduce the cost. And there we have pretty challenging things to do with Comsof, because we had a lot of special situations, different conduit types, and so on. And all these informations had to be calculated or had to be taken into account by the Comsof Fiber Designer. And I really must say that Comsof did a good job here and gave us a lot of support to understand these different situations and how to handle these in an automated way. So in this case, thanks to Comsof again for supporting us here. So now let's go back to the slides. So we generate our FTTH network design here. So as you can, sorry, one slide back, thank you. So as you can see on the screen, we have our distribution points, distribution areas. These are the colored polygons and so on. So all this network design is calculated automatically, and no telecom employee has to do it manually. And our telecom employees only do a short quality check on this automated network design, and that's all our employees have to do here. And now you can go to the next slide, Beto. Okay. The next step during our automated FTTH rollout process is the so-called Standort- und Wegesicherung. So there's no real good English term for it. So we have to ask our local authorities where we can put these cabinets and so on. And there we also use our gathered data we collect via the cars. And we have this tool here, so-called Fiber 3D. And then this tool, we can really change the position of each cabinet in a 3D way, so that we can really say, okay, we want to place this cabinet here, and no one is blocked by this cabinet and so on. And in previous times, our colleagues always have to drive into town and take these photos manually and also draw this cabinet on a PDF file. And we found a nice IT-supported way here to do so that our colleagues don't have to do this anymore. And this was also real beneficial during the pandemic. So we could coordinate the locations of these cabinets together with the local councils via the internet, and no one has had to meet on-site. And what we do here, so we approve these locations by the local authorities, and then we transfer these locations back to the Comsof designer, so that these changed locations are taken into account in a new network design. And another benefit of this 3D software is that we can record the conditions of the road before the rollout. So for example, if a local authority says, okay, my street was in a better condition before your rollout, please do it again. We can prove, oh no, your street was not in a better condition. You can have this picture of it. And another addition you can see in the video is that all the cars are blurred. So first we wanted to blur only the license plate, but this was quite challenging because the license plates have different designs in each country, so that we would have to gather a lot of training data for our automated blurring. So, and this was so huge effort that we just decided to blur all the cars, because cars look mainly the same all across the countries. And the last step I wanted to show you here is this document you can see on the left side of the screen. This document is also generated manually. In previous times, this has always had to be created manually. So this is really created automatically, and then our employee can send this to the local authority, and then the local authority can sign this document, and this is really the approval that we can build our cabinet at that location. Yeah, on the next slide. Yeah, the last step of our planning process. So after all of our locations and paths and so on were approved by the local authorities, we go to the detailed planning. And this software is so-called PlanGo. And this is based on QGIS. It's a telecom-made, telecom-tailored solution for detailed planning, and where we just import the network design created by Comsof. And the main thing the users do in this detailed planning is they just change a little bit, if necessary, on the network design. So just small things. As soon as some bigger changes are necessary, then of course we reuse the Comsof designer to just generate a new network design. And we also generate the construction documents out of the software. And the last thing that I wanted to show you here, that the software is multi-tenant. So also externals or other companies which work together with Deutsche Telekom can reuse the software. And yeah, the effort here has also been pretty reduced, because with our old detailed planning software, we would have such an equal construction area. An employee would work up to 300 working days on the design until this construction documents are generated. And now we could reduce this effort to an average of 30 days, also because Comsof is calculating so many components inside this network. So as previously said, so we know where each fiber is going and how it's connected, so that we really could reduce this effort up to 90% to 30 man days. Yeah, and the next step in our FTTH planning process would be the digital trench recording. And here I would hand back over to Bertolt. Thank you.
Thanks a lot, Henning. So yes, the next step is basically then the digital construction support, which basically consists of two main components. So we have, on the one hand, a mobile application So we, or together with a partner, we implemented a system. This one's called GeoAce, which supports the automatic measurement of open trenches and open constructions. You basically just have a mobile phone, you walk along the trench, the open construction, and it records using the LiDAR scan of the iPhone. It records the trench three-dimensionally and is capturing also relevant data and supports submitting that into our web app. There are also alternative solutions available for this. So we support GeoAce, the one that we also work together with our partner with. But there's also Deep Up and potentially in the future other solutions that we then support. That data is then submitted once captured into our digital construction web app. And so the benefit of this whole solution for us is that on the civil engineering side, it's a much easier and much more streamlined process to actually get the data to us. You don't need a field surveyor in every instance. In most of the cases, it's sufficient to just take this application and scan the trench and submit the data to us. And in this web application where then the data is being received from on our end, we have our construction supervisors working with it, and they see directly what is the current state of the construction. So where's it's a live progress monitoring. We can identify which construction method has been used. We directly can see all the images being taken in the field. We also see what was the planned network and where deviations to that. We can see the meter measurements. It's basically giving us the overview of the complete construction happening in the field. And also in cases where we need more details and need to do more, for example, quality assurance in what has really been constructed, we can dig into the information directly or the data provided by this application towards the web app, and we can directly go into the trench and do, for example, measurements. Has the construction really been as deep as we asked for? Is the trench as wide as has been submitted in the invoice? So it helps us basically doing quality assurance, helps us doing reconciliations of the invoicing process, and is then also later on being used for the documentation process towards our physical network inventory. So we can, in case of questions, we can always then dig into more details on how did the trench actually look like when it was still open. And that was basically, in a nutshell, the quick run through of the entire program of the FTTH factory. And with that, I would then pass back over to you, Ralph.
Yes, thank you, Bertolt. Thank you very much for that run through. It's really interesting to see how this process was further improved and how the end-to-end combination of these technologies really helped you automate the process. So I would just summarize some of the key takeaways here. I think when we started this project, having an ambition to go into millions, at 3, 4, 5 million, we've seen actually reached now of throughput for FTTH design. At the beginning was, of course, very challenging. These are big numbers, and it's great to see that we actually achieved that by working on the whole automation of the processes. And that has resulted in several reductions. We've heard a lot of different numbers. I'm highlighting here a 75% reduction in the design effort, but obviously you can see that there's a lot of optimizations in a lot of processes, which are really showing the potential of this kind of technologies. And last but not least, I think it's great how you showed also the importance of gathering data at high quality, and how that helps to also improve the overall quality of what you're generating in your process, and driving the efficiency of the processes. So thanks for sharing that. That's really great. And with that, I think we can take some questions, I guess, from no doubt from the audience. Vincent, have you had a look at that?
Yeah, absolutely, Raf. I think we already have some questions, so I'll start very soon. But I just want to encourage even more participants to ask their question. Use the question box in the control panel. As I said during the introduction, even if we cannot cover them, although we have 25 minutes to take quite a few questions, so it's going to be very engaged. Please do not hesitate to ask your question. So I'll start with the very first one, question from Aditya Rana. How do you check external lines?
Okay, how do you check external lines? Do you get the question, Bertolt? I'm not sure what.
I'm assuming, how do we check whether there's is already something in the ground when we do our construction, and don't mess up the infrastructure of other competitors or other infrastructure providers?
I assume, but the question is very short. There's no extra context. Sorry about it.
Henning, maybe towards the planning process, you can probably elaborate how we when do we get infrastructure from, let's say, local water and gas companies, and how do we make sure that we
yeah, this is made during the approval process. So in Germany we have to approve each trench we made. So not only the location of the cabinets, but also the trenches we made. Each meter has to be approved by the local authorities. And of course, most of the local authorities know their city. They know where, for example, some gas line is present or something like that. So here we get our first information if there's already something in the ground that might be damaged during our construction process. So this is the first step. And the second step is during the construction itself, each construction company have to ask, for example, the power provider, if there's something in the ground. So we have some kind of two-step system here to avoid damage to some other infrastructure.
Yeah, maybe I can add from a more broader perspective that it's indeed often part of the cycle. For example, what we've seen as well is with network deployments, which maybe go on poles or on aerial or on facades of buildings, which are part of the design, but then no permit or the poles are not able to take those cables in a later stage. I think the power is that you always have to be able to adapt to this kind of new input and rapidly redesign, taking in new information of where you're blocked or where you can't go. And I think that's what is really easy in this kind of automated process, because if you change the input, you adapt the options, automatically you can recalculate the whole network end to end within minutes.
Okay. I have a question from Luc related to how the AI work in a city center environment where there are typically many parked cars, which could cover sidewalks. So what is he's talking about percentage of success is in a variety of environment, and how do you work out the situation he described as non-successful street?
So we do have, I mean, that's one of the reasons that we don't use a smaller car like I don't know, a Golf or anything like that, but that we actually do rely on having a Sprinter, because the cameras are then so far higher up and we can actually see behind cars, in many instances at least. But in addition, we also have aerial data available. So in cases where our car cannot be used, for example, also pedestrian zones, or these cases where there is a large blockage or a truck parked on the side, we then use aerial data in addition in the classification process. And yes, then it's extrapolation of the data. So there is obviously some instances where we don't have the data and where we then just have to extrapolate on what we see in the surrounding and use that information.
Okay, very clear. Question on duct infrastructure. Is it taken into account by Comsof, or how is Telecom handling the duct infrastructure within the planning?
Well,
so which infrastructure?
I guess the underground infrastructure, I assume,
okay.
in the question.
Mm-hmm. Mm-hmm.
Yeah, maybe I can kick off because if I understand the question correctly, it's indeed, can we take existing ducts into consideration? And the answer is yes. We will add as a separate layer in the design process information about where existing ducts are geographically, and of course if they have a certain capacity, and then that will be considered within the whole automated calculation of how the network looks, because that is obviously in some cases an extra cheaper way to reach a certain point. But I think, I think Bertolt and Henning, you already alluded to it, that there is a lot of complexity in how you can actually use them. For example, some customers have certain ducts which they are okay to break open somewhere halfway to go out, or they may not allow that. That, for example, would already be a completely different way of treating this kind of information in the design optimization. So I don't know if you want to add a little bit more on how you exactly treat those ducts at DT.
Yes, maybe I can give a little insight. So as you've already maybe seen on our slides, this whole topic of existing infrastructure was pretty challenging for us because Deutsche Telekom has a lot of existing conduits and ducts already placed all around Germany. So how we handled this, so as Raf already said, there's a separate layer for existing infrastructure, and we import all of our existing infrastructure from our inventory system. So we have an interface here, and this is also transferred manually. So the planner or our employee only defines the area in which he wants to have our existing infrastructure imported, and then we just import it out of our inventory, and then it's taken into account by Comsof, by the fiber designer, in an automated way. So there are some attributes which have to be filled out. So for example, the capacity of an existing pipe, and then we know, okay, there's, for example, one existing pipe which has a capacity of 100 millimeters, and then the Comsof designer tries to use this existing pipe in a cost-efficient way. Yeah. So it's pretty nice, the solution which is available here.
Okay. There's a mix of very technical, very precise question, and some questions are more general. So maybe I'll insert this one in the conversation. It goes a bit beyond what is covered today, but the question reads, what is the competitive environment in Germany? Do you have multiple operator building networks? Are they overbuilding in the same location? So maybe a more general context to what you've been describing here.
So yes, we do have a competitive environment, and yes, we, even though it's hopefully not often the case, but there is also a happening of overbuilding. There's basically two main programs in Germany. So one is where we and all the competitors basically make their plans for themselves and say this area is promising for us, so therefore we're going to do a self-funded rollout. There's in addition subsidized rollouts that are subsidized by the government, and you have to apply for these rollout areas, and only one of the competitors would get the subsidy and would get the or would then obviously start to build out this area. Most of these cases, otherwise the area would not be as interesting. and therefore it's only one company actually doing it. I think you want to add something?
No, it's fine.
Okay. How often do you have to alter, to modify your design path after doing a field check? So
Not so often. Not so often. So of course there will be changes in each network design. So not I didn't experience even one network design which was 100% built outside. So there will be always changes to the network design, and to which step we have to go back. So if there's only small changes, then this can be done in the detailed planning. So for example, if there's a construction site on the planned route, then of course we have to go to the other side of the street or something like that. We have to find another way to connect our homes. So there are always changes in the network design itself, but we didn't have to go back and generate a completely new network design yet. Although our rollout areas are pretty big, but all these changes could be done either by the detailed planner or by the construction company itself. So I really did not experience any construction documents which have to really go back to the high level design step we do with Comsof.
And I would like to add to this that I think there indeed what you presented in terms of an end-to-end process is really helping that, because of course everything depends on the quality of your input. If you want to run an automated calculation, but you do it on input data which is not which already starts with having not all the information about the area, then of course you end up with choices made based on data which is not correct, which can also result in wrong choices. And in that case, field survey is important to actually update that. So for sure, we have customers who will have to correct maybe 30–40% of the field survey in terms of rerunning and iterating on the design. And we support that in an as easy as possible way. But I think here, it's really great to see how the process also is optimized to get that data quality on the input side as good as possible. And that will reduce, of course, the work you have afterwards to correct things.
Okay. I have two questions which I would like to combine maybe in one. There is a first question related to, which probably is linked to the fact that the person asking is not very familiar with the detail of the construction method and regulation in Germany. So are you able to reuse existing duct? Do you reuse poles? Or do you need to go for new duct every time? Are there possibility or impossibility to use overhead routes? So that's one question you will address. And I have another one which is a bit larger, but based on your experience and your knowledge maybe of what happens in other countries in Europe, what sort of takeaway would you share with operators from other regions, from your experience that is presented today? So maybe that's something Raf can complete on. First question on how do you roll out and what method of deployment you have to use?
Yeah, so in Germany, obviously, most of the construction is underground. So there's very little appetite for doing aerial constructions. If so, then only in rural areas, but all over the cities, and I would say probably 90%, probably more, is underground construction. And yes, we definitely want to reuse our existing infrastructure and our existing ducts. I mean, that's the main asset that Telekom already has in the ground. It would have been so much easier to just ignore that infrastructure from a IT program perspective. And we even in the beginning thought about wouldn't it be for a first step be easier to just say, okay, the first areas we just do always open construction, but that's the main cost saving that we can apply in Deutsche Telekom, because we have such a vast infrastructure already in the ground. And therefore, yes, we definitely want to reuse it. We also, over time, implemented methods to also reuse partially available infrastructure, which may be already partially used and it has still some spare capacity. So that's one of the main things that we had to introduce into the overall program to make use of the existing infrastructure. And that is also already available in our physical network inventory. And sorry for the second part of the question.
The second question is, what sort of guidance, takeaway can you share with maybe, you know, other operator having maybe slightly different infrastructure rules from your experience of using these kind of tools?
I can maybe just from the perspective what we had also talking to our NatGos across Europe, where we also wanted to or talked about introducing this progress and process stream. We did have these interactions as well, and in other countries there are obviously different rules on how much do you have to do underground. We had conversations where we said, okay, for us, it's really important to understand what the surface type is, because depending on the surface type, the reinstatement is quite, from a cost perspective, quite different. So cobblestone is obviously much more expensive than plowing through grass. And what we had from some of the other countries, we had the feedback, well, for us, it doesn't really matter what we use to reinstate the surface back into, and therefore we don't need that detailed information. So it obviously depends on local requirements, but for us, yeah, one of the main cost driver for the whole construction is the underground construction, and therefore the cost driver is reinstatement and of all of that, and therefore we needed that detailed information that may be different in other areas where that's not the case. Raf, do you want to take that further on the?
Yes, well, I certainly can agree with you, having looked at a lot of deployments in different countries, that there is a big difference. Also, a big difference in the way indeed the choices are made and optimization is driven, because unit costs, for example, could already be, even within two countries building underground networks, the balance of unit costs could already be quite different. Because of, for example, access to cheaper labor, or, for example, the depth at which you need to deploy. If you can do micro trenching that is 30 centimeters deep, you get a completely different cost for an underground network, and that will actually drive different decisions in the optimal topology. So all of these local differences are important to consider when you look at the local situation. But I would also highlight as a takeaway for other telcos and looking at what has been done here. I think what is really nice is to start a bit with the end in mind. That's what I always like to do, is looking at this, okay, what do we want to achieve, and what will the end-to-end process look like, and think about an integrated solution that can cover that end-to-end process. And then if you would look at the history we've had through the 5 years, of course, the solution did not fall out of the sky in 1 year. So I think what then is an interesting takeaway, that you can actually start off with something and then gradually add more components into the process that further improve the speed and the accuracy of the process. And thinking that through and really thinking out how that process should work, and doing that in a fully digitized way, because hey, well, we're 2023, almost 2024. So there's a lot of benefits of thinking that through really well and then implementing it phase by phase, so to say.
Okay, thank you. Another question for you, Bertold. Question about how has your, the question reads, how is your demand changing in 23 versus 22, and how do you foresee 24? I guess by demand they are thinking about activity and investment plan in fiber.
Yeah, I mean, as you could see from our figures on the first slide, we're constantly ramping up. I mean, we've been, I think it was 2.2 million this year, and last year it's going to be more likely 3 million next year. So demand is obviously constantly ramping up. I mean, the goal for whole of Germany, for all of the competitors in Germany, is that all of Germany should be connected to fiber by 2030. So that's still a long way to go, and therefore I think the demand for us in terms of construction is constructing the network is definitely high, yeah. So the plan is to have more and more people also being then not only constructed but physically connected to the fiber. But I'm not sure that it completely addresses the question, but yeah.
But I think that was the spirit of the question. I have another one which becomes much more technical and practical from Molly. She's asking what percentage of the process remains manual? If you look at the different stages of preparation and planning, what part is still done really manually?
I mean, for that, maybe that's a big lesson learned for us. When we started off the program, we had the intention everything should be automated. We want to run the entire process stream automated. We want to do also documentation automated, and only the very few deviations we would then try to make them manual. And we learned over time that this was also not feasible, also with our existing processes and with the way how the planners and designers and everyone has been using the systems in the past, and therefore we had to open up the whole stream for more flexibility, because if we were to go for the fully automated process, there would be only one process and only one way of doing it, but we didn't have any flexibility anymore. And therefore we had to open it up again and to allow for more flexibility, but that also then means more manual intervention, which is also asked for by our planners, because the program wouldn't every single time do the right decision. You end up with cabinets that from all the aspects that we just learned on the map and everything, they look perfect, but then if you go to the field, you realize they're standing in front of a shopping window and you can't see the window anymore. So you need flexibility, you need changes to be possible, and therefore we had also our detailed design is now not completely automated. It's a set of tools that helps the designer to be much more efficient and much more quicker, but it's still a manual process. And we changed to that manual process. We had it more automated, and we didn't have any user acceptance with that process, and we are deliberately now into a semi-automated process. And trying to tweak that further and help giving more efficiencies to the planners, but still allow them to do the planning job manually.
Thank you. I'm just conscious of time. I would like to give you the opportunity, Bertolt, to look ahead and maybe share with the audience what are your plans in terms of maybe further integration of IQGeo tools or further improvement in your processes moving forward. How do you see the evolution for the next 2-3 years in terms of your methodology to gain more efficiency and be faster and lower your costs?
So in terms of integration with tools, so for example, Comsof Fiber has been integrated already since 2020, and it's fairly stable and works perfectly for us now, and that's the valuable piece for us to start the whole process. So I would say our structure planning is very stable and probably needs tweaking over the next couple of years wherever we change network design rules. But the main integration component is more or less achieved in that component. Same for the detailed design. I think that runs very stable and smooth, and we will have further efficiencies there, but the integration is more or less completed. What is our main component that we are building right now is the whole area around the digital construction support. And a few of the components that I mentioned before are not up on early stages of MVPs and piloting, and so the whole integration of that component Then also integration with our P&I system to do the automated documentation, integration with some invoicing components. That will be taking most of our energy and time for the next year, I believe.
Well, thank you so much. Ralph, maybe I give you 1 minute to conclude, so we close this session on time.
Well, first of all, I would like to thank our speakers again, and I think it's been illustrated also by the amount of questions that there's a number of unanswered questions, which I think we'll cover later on. But I think it's been great to see the interaction and the questions for this topic. So there's clearly a big interest. I think it's really an illustration. It's been a journey, as the title said, of many years where we got to that stage now of high productivity and a great example process. So we're happy to share a bit more details how that went on individual basis. For anybody that has questions, feel free to reach out. And with that, I'd like to thank also, of course, the audience, and look forward to more of these kind of webinars into next year, no doubt. I hope you're working on that, Vincent.
Well, absolutely. We have, replay of our webinar available via our website. I would definitely also encourage our audience to check our website. A lot of content covering this type of technical discussion, but also many other aspects of FTTH in Europe can be downloaded for free from our website. So don't hesitate to check. And watch out for the next invitation. We will have a webinar in January on another topic. So with that, I thank you all. Many thanks to our speakers. Wish you a good end of the year. Merry Christmas. And I hope to see you all, well, maybe next year in Berlin when we have our annual conference at the end of March. So I'm sure Deutsche Telekom will be well represented among speakers and audience there. Thank you so much. Have a good rest of your day.
Thank you very much.
Thank you.
Thank you.